Good afternoon or good morning, depending on where you are. Thank you for joining us. We're excited to share another SQL Server webinar with you. This is something Randy's excited to share.
All right, well, let's go ahead and get started. We like to reward punctuality at SSG, not make people wait who are on time. Unless it's me that's late, then people tend to wait, but probably shouldn't be that way. Anyway, we're SSG. This webinar, if you haven't attended one of our webinars before, is part of a monthly series that we do on a variety of topics. This one is kind of an oldie but a goodie. I've done this presentation for years and just kind of, updated it as SQL Server features change and whatnot. But the, somewhat humorous but familiar title, but it worked great in dev, right? And really what this is about is for developers who maybe aren't as familiar with SQL Server under the hood, what are some kind of anti-patterns that we want to avoid when writing our T-SQL code? So, for those of you who don't know me, my name is Randy Knight. I am a Microsoft Certified Master in SQL Server, if you know what that happen to know what that means. This says 20 years of experience. That's probably a little bit dated. I've been working with SQL Server since about 1995, 96, somewhere in there. And so have been doing this for a very long time. Enough to be so-called vintage, as my wife likes to say, that I'm a vintage IT person. I have done a bunch of things over the course of my career. Most recently, prior to starting this company, I spent 6 years as a database architect for a company called Match.com that you're probably familiar with. And that was fascinating data to work with and culture and everything else. But also, we were serving up 50 million or so pages a day, all out of the database in SQL Server 2000. So definitely scaling SQL Server beyond what it was supposed to be able to scale even back then. And of course, it's a very different product now. In 2010, I started a company called SQL Solutions Group. We're a Microsoft certified partner. We are hyper focused on the Microsoft data platform, SQL Server, the Azure offerings, some of the BI stack we do things with, but we do just data and just Microsoft data. We don't do other DBMSs. We don't do application development. We don't sell Office 365 licenses. We do data, and we think we're pretty good at it. Some of our offerings, full scope project consulting. This is kind of our bread and butter. We also have a remote DBA managed service and health checks, which typically with our customers, we start with a health check because that works well. And we also have a coaching program where, unlike training, this is more mentoring, one-on-one, working with you in your environment on the things on your projects. So it's a little bit different than just a training program. So if any of that has any interest, obviously one of the reasons we do these webinars is so that people will be aware of us and what we do. And that's enough of that. Let's get started. Okay, what we're going to do today, first thing we're going to do is we're going to talk about some of the fundamental differences between T-SQL or database code and application code, something like C# or Java, whatever you happen to be building your front end or middle tier in, and why those differences are key to understand. We're also going to take a very brief look at execution plans. We're going to talk about indexes. And then we're going to go into what I call the 7 deadly SQL sins, meaning 7 things and that are kind of anti-patterns, as I said, that we want to avoid. We're going to go through an exercise starting from a very simple query. What is the process that I would go through writing a query for Management Studio or Azure Data Studio? We could use Azure Data Studio as well, or whatever, tool. But we do want to go through this process using a DBMS tool, because we're going to look at some things like execution plans and IO, some different things in terms of how SQL Server works behind the scenes. This is just a taste. Obviously, we're not going to have in 1 hour, we're not going to go in depth on execution plans, on indexes. We're just going to, point out some key things that we're looking for. And, hopefully these things will be inspiration to say, hey, I need to go really learn more about X. And one of the things that we always welcome are any suggestions for future webinars. So, if we go through this and it's like, I get this execution plan thing kind of, but I'd really like to be able to do a deep dive on execution plans, let us know. And we'll do a webinar just on execution plans. Okay, a couple of quotes on database development. The first one, knowing how to write T-SQL does not make you a database developer, it just makes you dangerous. And good hardware can never completely overcome bad code. So we've all seen that whenever there are performance issues, we like to just, throw hardware at the problem. And that can be okay temporarily. But if we're talking about things that I can reduce the IO exponentially by tuning a query or by doing things, in a more optimal way, there's no amount of hardware you can throw at that to accomplish the same thing. So we really need to make sure that we're, being as efficient as we can be in our query development. All right, so what are some of the differences between database code and application code? And, we're not talking about syntax here. We're talking about just the fundamental approach. Application code, when I write code in C# or whatever language, I'm telling the compiler what I want to do and how to go about that. Do I want to use a loop here, or do I want to, what type of collection do I want to use? How do I want to go through and process this information? It's procedural, it's object-oriented, right? We try to abstract the data as much as we can. Object relational models or ORMs, such as Entity Framework and Hibernate. There's many other open source ones that are the names are escaping me right now. But the whole idea is that we have this model and we have classes, right? We have objects, we have collections of objects, right? Everything that we're doing in our application code, we're not really thinking about this in terms of the physical data structure, in terms of the tables, in terms of indexes, in terms of relationships. It's very abstract by design. When we get into the database world, things are quite different. SQL of any type, not just T-SQL, any relational database, is a declarative language rather than procedural. What that means is I'm going to tell the database engine what I want. Here's the data I want to retrieve, the columns, the rows, from the tables, the predicates, the filters, so forth. I'm going to define what I want. And there's a whole operation that goes on behind the scenes where the database management system decides what is, it hopes it can figure out the best, most optimal way to give you that data. It's set-based versus procedural, right? So we're operating with sets of data. And a lot of times where developers tend to get themselves in trouble is using loops, because that's what we're used to, is operating on an object at a time. And set-based operations are going to be much, much more efficient. Physical data storage, physical structures are very important when we're dealing with T-SQL, right? Whether that table has 500,000 rows or 500 rows is a very, very important distinction, right? I can get away with things with 500 rows that I can't with 500,000 rows or 5 million rows, right? So understanding the quantity of data, the distribution, the cardinality, indexes, statistics, all of those things become very important. Okay, what's an execution plan? We can look at estimated execution plans, which is going to show us how the DBMS is probably going to complete the operation, or how it thinks it's going to, or the actual execution plan, which is what it actually did. What the execution plan is, I talked about SQL being a declarative language. So what happens is we tell it what we want, and then it goes through a process called the optimizer. The query optimizer takes that query and takes what it knows about our database, how many rows there are in those tables, statistics on the distribution of the data, indexes, all of those things, and it comes up with an execution plan, which is what it thinks will be the best way to retrieve this data. And here's the critical thing. We talked about this concept of 500 rows, 500,000 rows, 5 million rows. The exact same query is potentially going to come up with a different execution plan in each of those scenarios. So one of the things that I hear a lot, that we hear a lot, and we probably all do, is, you know, everything in this application was working fine until last week when we started to have performance issues, and nothing has changed. No hardware has changed, no patches, no updates. We haven't changed the code. I don't understand why this would happen where nothing has changed. Well, the answer to that is that there is something that is always changing in an operational system, and that is the data, right? Many times in those kinds of situations, what's happened is you've reached what I call a tipping point in performance. So going back to what I said about, you know, with small quantities of data, you can get away with things that are not good practices, that are not best practices, that you can't get away with large amounts of data. You know, I mentioned my time at Match.com, and, you know, such a high concurrency environment, you know, you learn very quickly what you can get away with and what you can't in that kind of an environment. Okay, what impacts the execution plan? Quantity and distribution of data, we talked about that. Indexes, statistics, all of those things are things the optimizer is going to take into account when it builds an execution plan. Also things like the version of SQL Server we're on. You know, in SQL 2016, I believe there was some pretty major changes to the optimizer to the point where they put in an option that you could use the legacy cardinality estimation because it had changed so much that there were potentially queries and things out there that performed worse in SQL 2016 until we have the opportunity to rewrite those for that optimizer change. Okay, that brings us to the 7 deadly sins. We're going to go through these pretty quickly. This webinar is going to be a lot of demo because that's really the best way to see what's going on under the hood. So the first one, and I would say in the advent of Agile software development, this has become an epidemic, and it's poor or no database design. It's really important to model our data based upon the data itself and not just on how we're going to use it. And what I mean by that is I'm writing an application, and I sometimes ask the question in these sessions, what is a database for? And that sounds kind of silly, but many times from a developer's perspective, the answer will be, oh, it's to persist state, or it's to save data so that my application can retrieve it again, right? It's a very application-centric focus on that data, how I'm using it as I create that table. And the challenge with that is that over time, that's going to change. The applications change, applications go away, data tends not to, right? We all have had experiences, if you've been doing this for any period of time, of dealing with data models and databases that were built 20 years ago, and we have to go through all kinds of hoops and circles and do crazy things in our code to get the data the way we need it now for this application or for this report. So good old-fashioned data modeling, normalization, third normal form, right? Our good friend Cod, who was the guy at IBM that invented relational databases. So here's a great example. This is from years ago, but I came across a table that had no primary key, no foreign keys, no indexes, and the characters, the varchar columns, had a different collation than the database itself, or the other tables in the database is another way to look at that. That last one is really interesting because you have to work at that, right? That's not something that's just, omission. And so I was trying to join to this table for a report or something like that. And there's, no keys. So I was just trying to figure out what's there. But more importantly, the only thing that was there for me to join on was a string character-based column. And because it's a different collation, now you have to specify the collation. It has performance impacts. There's some different things going on there. So I went to the developer and I said, hey, what's going on here? What was your thought process in putting this table together? This is a verbatim quote from a instant messenger chat. I was just creating a pile to put the data. I wasn't thinking about how it was going to be used. And, I had to bite my tongue and say, well, you created a pile of something, but this is textbook what happens when I'm only thinking about this from the standpoint of my need. That, I need to collect this data and stick it somewhere. I'm just going to stick it somewhere and not really think about why it's being put there. So database design is important. Index design. We can have too many or too few indexes. And we've seen both. Too few, we're going to end up doing a lot more work, doing a lot more reads, doing a lot more things than we need to get at the data we need. Too many, there's a couple of things that can happen there. One is, and typically where this comes from are things like missing index hints or the database tuning advisor, where I know just enough to be dangerous. So I say, hey, this query plan says this index is missing, so I'm going to create it blindly without understanding what the potential impact of that might be to other queries or to writes. Every index that exists has to be updated every time there's a write activity. Insert, update, delete to your table, insert, update, delete to every index on that table, right? The other one is the database tuning advisor, which is the same idea, but just on at massive scale, that we feed it this activity, and it comes up with this list of suggested indexes. And I can't tell you how many times I've seen tables with literally hundreds of indexes with, underscore DTA in the name of the index, which tells me it comes from the database tuning advisor. What that tells me is that someone ran the database tuning advisor, it made some suggestions, we blindly went and applied those index changes, and it fixed things. Great. So then we went along for a few more months, things started to get slow. Hey, that worked great last time, let's do it again. And we end up with all these indexes. And the other thing, besides the overhead of having to maintain those indexes that we have to think about, is the optimizer. The optimizer's job is to come up with an efficient execution plan. It is sometimes misstated that the optimizer's job is to come up with the best execution plan. The optimizer's job is to come up with the best execution plan it can very quickly, right? If it goes through and it checks every possible combination and it comes up with an execution plan that can execute your query sub-second, but it took 30 seconds for it to come up with that plan, that kind of defeats the purpose, right? So the more indexes I have, the more statistics I have, the more possibilities there are going to be exponentially, and the more difficult it's going to be for the optimizer to come up with a good plan, right? So indexing is important and is clearly a topic of its own. Database tuning advisor run amok, indexing without understanding your data and how it will be accessed. Indexing is more of an art than a science sometimes. If you have a missing index suggestion from an execution plan, that's great as a suggestion, but you need to understand your data and how it's being used, not just by your application, but by other applications, by reporting, and throughout your application, not just for that particular query. Poorly chosen clustered indexes. Clustered indexes are it's many times stated that they determine the physical order of the data on the disk. That's not technically accurate, but it's good enough for our purposes. It determines the order of the data. So we're going to look in a demo at what a poorly chosen clustered index, some of the impacts that can have. All right, loops, cursors instead of sets. We talked about that. Can you always solve a problem with a set? Technically, some people will say you can. I would go so far as to say there are places where you need loops. But what I would say is if you think it has to be a loop and not a set operation, justify that to yourself. Go through that exercise of, I should be able to do this with a set operation. What's my justification for not doing that? Not using explicit column lists. Select star is a really, really easy shortcut. And the problem with that is many times we're going to end up retrieving more data than we need. This is particularly true with the overuse of views, right? I have a view that brought all this data together, and hey, look, that view has the stuff that I need. I'm just going to write my query against that view, even if it maybe it has extra columns that I don't need, maybe it has extra joins that I don't need. And so when we say select all columns, with that wild card, we're saying give me everything, even if I only need 3 columns. So that has an impact on memory, network, but more importantly, we tend to think of it that way, it has an impact on execution plan, right? And we're going to look at an example of that. Misuse of non-deterministic functions. This could be in the select statement, which basically means I'm going to execute this function for every row of your results, which means you think this is a set operation, but we've actually turned it into a loop in that this function is going to execute for each row. In the where clause, it's going to be impossible to use an index. In that case, it's going to be a table scan. Number 6, linked servers. Linked servers can be very useful, but when misused, they can cause real problems. The biggest issue here is when we're going to hit large tables through a linked server by just joining to it or select from linked server.table, because the optimizer that's creating that execution plan is on the local machine. It doesn't know anything about that table on the remote machine. It doesn't know if it has 5 rows or 5 million rows. It doesn't know what indexes exist. It doesn't know anything. And so when I do that, even if I have a where clause, even if I have, I've written my query as efficiently as I can, it's going to do a table scan on that table on the remote side. And so there are ways to work around that with things like open query, but the misuse of linked servers is one of the things that we see a lot. Last but not least, dirty reads. This is referred to in lots of different ways. Read uncommitted, transaction isolation level, adding the no lock query hint, or we could just call this, who cares if it's right? I don't really, the data that's coming back to me being accurate is not important to me. And that sounds like hyperbole, but it's really not, and I'm going to prove that to you, right? Somewhere along the way, it became this article of faith that no lock is the way to make SQL Server go faster, to avoid locking, to avoid concurrency, but it has a lot of unintended consequences that you may not be aware of. So we're going to look at that. And then the last one here I added for this webinar is implicit conversions, because that's an important one. Whether it's explicit or implicit, when SQL Server has to convert between data types at runtime, if it doesn't have the data types the same prior to the time that it creates the execution plan, many times that's going to end up in a suboptimal plan. And that's just something that, to be honest, many times it's laziness, and I've been guilty of this too, right? That I just say, hey, this is a date time when maybe in the database it's a string, right? So it's important that I get my data types right. Okay, we're almost to the demos. We're going to use SQL Server Management Studio to write a query. We're going to execute a command called set statistics IO on, which will tell me the IOs involved when I execute a query. We're going to display the execution plan. And we want to make sure that when we are writing our queries, or at least when we're optimizing and we're looking at performance, that we have the same or similar quantity of data, indexes, statistics, etc., that will exist in production. This is the #1 source of that but it worked in dev statement, right? Because with a very small amount of data, test data that's been created in my dev environment, things may work great, but when you get into your production database that has millions of rows in these tables, you run into performance issues. Okay, with that, we're going to switch to SQL Server Management Studio, and I'm going to make that a little bit bigger. Hopefully everybody can see that. We're using the AdventureWorks database. Microsoft's demo database that they've used for years. And the reason that I use that is so that you can download these scripts and play with this yourself. Okay. I'm going to just make sure I don't have this index left over from last time that I used it. I'm going to make sure my statistics IO is turned on. And what that does is if I just get all the rows from a table, sales order header table, I'm also going to go to my query menu and say I want to include the actual execution plan. I'm going to execute that. I get my results back, 31,000 rows. If I go to my execution plan, it tells me the query, and each of these guys is an operator of what it had to do to get that data. Now, in this case, we have a clustered index scan, which is actually the right thing to do because I said I want every row, every column, right? I want the entire table. So the most efficient way to get that is a clustered index scan. Okay. So now let's say, okay, well, actually, I just want the information for the orders for this account. Before we do that, on the stats IO, if I go to the messages output, what stats IO does is it tells me for each table what were the reads. And what I'm going to care the most about are logical reads. Logical reads are reads that it was able to read the page from memory. Physical reads, it had to go to disk. So the more I can reduce my overall reads, the better off that I'm going to be. This number refers to pages. SQL Server stores data in pages, which is a kind of a sector or a section of the database that are 8 kilobytes, right? So you can actually take this 689, multiply it by 8. That'll give you how many K. When you're dealing with large amounts of reads, you can, convert that to megabytes or even gigabytes. Okay, so now let's say I want just this one account. Okay, I got 28 rows back that time versus 31,000. But what was the work that I had to do? If I go to my execution plan, it's exactly the same. We have a clustered index scan. We read 31,465 rows, right? We only returned 28 because we filtered it after we retrieved the data, but this was just as costly a query as retrieving everything. And it gives me this missing index hint. It says, hey, if you have a non-clustered index, that's going to be helpful. We'll come back to that. If we look at the IO, same thing, 689 logical reads, right? So let's take our missing index, and it says, hey, if you had an index on account number, that would really help. So we say, okay, let's create that index. So we're going to create a non-clustered index on account number. All right, we've got our index. Now we're going to execute that exact same query. We're going to get our 28 rows back. So one of the things that I really want to point out here, from a standpoint of my code that I wrote, there's no difference between these two. The difference is in the index. I can't know what the difference is without looking at an execution plan. So when you're looking at just your SQL query that you wrote, you're getting a small piece of the picture of what's happening. All right, my execution plan now has an index seek on that non-clustered index. It only needed to read 28 rows. That's fantastic, right? If we go back to our messages, we've gone from 689 logical reads to 96 just by having that index, right? We do, however, have a key lookup. This index that we created only has account number, which is the index key, and it will have the primary key of the table along with that. It's like the index in the back of a book, right? Look up this account number. Oh, that account number is on these 10 pages. right? And so it has to do what's called a key lookup 28 times, one for each row. It's going to grab that primary key and go grab the rest of the data that we need. All right, well, this brings us up to our column list situation. We don't need every column. So if we say I only want these 4 columns and execute our query, that helped. We only have, 5 columns versus all of them, right? But our execution plan is still the same. We still have a key lookup. We still have 96 logical reads. We can get rid of that key lookup if we want using what's called a covering index or included columns. So this time I'm going to create the index on the account number, but I'm going to include those other columns that I need as included columns in the index at the leaf level. Execute that. Now if we execute our query specifying just those columns, we don't hit the clustered index at all. We were able to answer everything happening in this query from this non-clustered index and 3 logical reads. Okay, so we've gone from 689 logical reads down to 3. Now, if we still were selecting all columns, we're going to be back to our key lookup. The covering index didn't really help us. And then we say, okay, 689 pages, big deal. We've got a table here with almost 1 million rows in it. Sales order header big. And I'm just going to make sure that I don't have the index there. Same select star query. Same execution plan. 21,000 logical reads. Now let's create our covering index, execute our query specifying the column list. We're back to the execution plan where we're only hitting the non-clustered index for 13 logical reads. So now we've gone from 21,000 down to 13. And when I talk about making changes that are exponential, we can do things where we're going from queries that are using millions of logical reads to, less than 1,000 in some extreme cases, right? So indexing is important, but more importantly here than indexing, I don't want you to take this and say, okay, I need to go create covering indexes for every query, right? Because indexing is an art. That might work great for this query, but it might have negative impacts on other queries or on performance for writes. So we need to think about this. But the real takeaway here on this how to write a query is that I have to look at the execution plan and I have to look at my IO, or I'm not really understanding what's happening in my query. Again, with the exception of changing to just the column list we need, this code is exactly the same for every instance of this query. It's the indexing behind the scenes that changed the execution plan that made it 13 logical reads versus 21,000. Okay. All right, that brings us to our next demo. This one is, and I haven't followed up to see if there's any Q&A, so let me do that real quickly. Looks like we are okay. 2 published.
Yeah, there's a comment so far.
There's what?
One comment from Aaron.
Okay. Yep. Yeah. Thanks, Aaron. Fantastic. Yeah, that's this is somewhat epidemic, right? In terms of just not even looking at what's going on. So Number 4, so this one we're going to look at is how we can turn what we think is a set operation into a loop without knowing it, right? So I'm in this same database, and I've got a couple tables. I've got a department table in my human resources schema. I've got department IDs, names, group names, so on. Should still be on, but let me make sure my stats.io is on. And if I look at my departments, and I also have an employee department history, right? So in my employee department history, I have an employee ID, which actually shows up as the business entity ID in this data model, a department, a shift, when they started, when they were terminated, so forth, right? And what I need is I need a simple report that gives me the employee's name, their department, and when they started. So if I look at just that employee department history table, I can get the IDs, but I don't have the employee name or the department name. So I'm a well-trained developer, and I know about reuse of code and doing things as object-oriented as we can. And so I think, hey, what I need is a way to, given a department ID, grab the department name. So I'm going to create a scalar function that does that for me, right? So I'm going to create a function called getDepartment that takes the department ID as a parameter, and it's going to return the name of the department for that department ID. This makes all the sense in the world from a .NET standpoint, from a, modularizing my code reuse. So I'm going to create that function. Oops, would help if I selected all of it. And I'm also going to, I don't know where that get state one came from. We're not even using that. Anyway, all right, so now I'm going to run this query again, and I'm going to grab the business entity ID, which is the employee ID, but I'm going to call this getDepartment function to get the department name. That's exactly what I wanted, right? Now I have the start date and I have the department name. And check this out. If I look at my stats.io, it was only 2 logical reads. Hold that thought. So let's do the same thing for employee name. We're going to grab the contact ID from the employee table, and we're going to concatenate the first name, middle name, last name from the person table, and we're going to return that value, right? So same idea as the last function. This time we're hitting the employee table and the person table to get what I need. And now I can call get employee name as employee name, department ID as department name, and so on. There's my report, exactly the way that I needed to have it. I did a great job, right? I created these functions that this is hardly the only place in our application that we're going to need to know an employee's full name or the department. So now I'm going to be able to reuse this function all over the place. And the best part is I can do all this with only 2 logical reads. You can probably tell that I'm setting you up with that. We're going to go over here to SQL Server Profiler. We could use extended events as well. One of the misleading items about statistics.io, it gives you the output from the last thing that was executed in that query. And in many cases, that will be a set operation, and it will give us all the information we need. I'm going to start this profiler trace. I'm grabbing statements, duration, and reads. And I'm going to execute that query again. let's also look at the execution plan this time. We've got our index scan. It doesn't, here's the other thing. The execution plan doesn't even tell me about access to those other tables that we know are happening in those functions. If I go back here to my profiler, take a look at what's happening here. Those functions are firing for each row in the result set and consuming 2 logical reads, 2 logical reads, 3 logical reads, 2, 3, and so on, so that the entire statement was actually 2078 logical reads. Okay, because each of those things are executing each time, right? What if I did this with a join? So in this case, I'm just taking my syntax, I'm concatenating my employee name, I'm grabbing the department name from the department table, and I'm using joins to do this. If I execute this, get the exact same data back. My execution plan is more complex because of the joins, but it's still pretty efficient. We have a seek on employee department. We do have a scan on the department table, which, you know, depending upon my data and how I'm using it, could be good or bad. That's a small table, probably always will be because it's department, so it probably doesn't matter. But I do need to think about that. How many logical reads? We had 915 on the person table, 16 on department history, and 2 on department, right? So little under 1,000. So in this case, our set operation, our true set operation, used about half the I/O as the functions. Now that doesn't seem like that big of a deal when we're talking about 1,000 reads versus 2,000. But what if we're talking about 1,000 versus 500,000, right? I have seen instances with, and this is what Aaron was talking about in his comment, where these scalar functions are being used in such a way that they're being executed millions of times per hour, right? Something like a get employee or a get customer function. And even if it is 3 or 4 logical IOs each time, multiply that by millions of times per hour, and it's a tremendous amount of IO. So again, we need to understand how SQL Server is executing our query behind the scenes. Okay, going on to one of my favorite demos. If this doesn't make you a believer, I don't know what will. What we're going to look at is no lock, right? And again, we're in this session, we're really kind of scratching the surface on a lot of different things. I have an entire session actually that I did at Past Summit years ago on transaction isolation levels, talking about the different levels: read committed, read uncommitted, repeatable reads, serializable, and then getting into the snapshot isolation levels as well. Read committed is the default isolation level for your queries. It's going to lock data, whether that's a row, whether that's a page, whether that's a whole table, for the period of a time it takes to read that data, and then it's going to release it, right? And when we do that, that can cause blocking. As I'm reading that data, I'm holding a shared lock. Someone else needs to write that data, and they can't until I release my locks. So there's this no lock table hint or query hint that says, hey, don't issue those shared locks, right? And these are called dirty reads because without those locks, I can end up reading data that is part of a transaction that has been written that has not been committed yet. meaning if that transaction gets rolled back, I now have invalid data. Most people seem to understand that about no lock. And they're like, in this particular case, I can live with that. It doesn't happen that often, on and on. What is not being taken into account is data movement. Data movement is when, remember that the clustered index, or indexes in general, determine the order of those rows on those data pages or index pages. As the data gets modified, that causes movement. If I need to insert a row between rows 5 and 6 on this page, I'm going to have to shift rows 6 through whatever down on the page to make room for that. If there's not room on that page, if there's not extra space, I'm going to have to allocate a new page to move the last row onto. That's called a page split. Okay. Without locking, SQL Server has no way of knowing that that page moved. So what happens is I end up in my results with missing rows from my result set because the data moved before I read the page, and I don't know about the new page, so I'm not going to read it. Or I could end up in an even potentially worse situation where I duplicate the data, right? I read it on the original page and on the new page, right? So let's take a look at this. What we have here, we have a table that I have appropriately named Evil No Lock. And this table has a horrible design. Don't ever do this. This is a contrived situation to generate a lot of page splits so that we can see what's happening here. What I have here is a simple table. It has an integer identity column and it has a GUID, right? That's not so bad. The table has 1,000,000 rows in it. Here's where it got bad. I am creating a clustered index on the GUID. Well, think about that. If I look at that data, and this is one of the problems with GUIDs as keys, the very nature of a GUID is that they're not sequential, right? We go from 562 to 1D6 to E24. So if I'm clustered on that, I've got some real issues in that anytime I add a new row, anytime I change this GUID, I'm going to create data movement, right? Which is actually what we want for our purposes. So I have 1,000,000 rows in this table. If I'm not inserting or deleting rows in that table, I would expect that query to return the exact same result every time, right? So I've got a loop here that's just going to continuously count the rows in the table with no lock and print out the row count. So we're going to kick that off. And we're going to see what we would expect to see. In a moment here, when these results start streaming, it's going to be 1,000,000 rows. There might be 1,000,001. Nope, there's 1,000,000 rows, okay, in that table every time. If I don't add or delete data to that table, I sure better get that same value from that aggregate function every time, right? We also have a SQL Server performance or a Windows performance monitor running here that's giving us page splits, right? That are happening on this server, right? What we're going to do is we're going to generate page splits by updating those GUIDs. So I'm going to go over here to a separate session, and I've got another loop. This one is going to update GUIDs in that table, and it just randomly, it's taking that ID mod 10, right? So it's going to update about 10% of the table each loop, right? And I'm going to kick that off. And if we go over to our performance monitor, we're going to start to see some page splits. Not a ton, but we do see them. There's 1, there's 3, so on. And we could change the scale here to see what's going on, or we could update more of the rows. But let's go over here to our row counts. We see we're getting 1,000,000 rows every time until we started those updates. Now we're seeing things like 999,824 rows. Because of those page splits, many of those rows moved out of the scope of this query because it doesn't know that there's new pages and got left out. We see cases where we have over 1,000,000 rows. Those are duplicates, right? So what this illustrates is that concept of who cares if it's right. And what the problem with this is, what makes it so bad, is where is the place that people say you should always use no lock so that you don't cause blocking problems for the application? And the answer to that is reports. Well, what do reports tend to have a lot of? Aggregate functions, right? Suppose this is accounts receivable, right? And I'm looking at the total amount that somebody owes me. I can understate that. I can overstate that. You know, what if this is how your bonus is being calculated? This would be nice, but it's Murphy's Law says it's more likely going to be like this, right? This is a very bad practice that you need to be, if you're using no lock, and I'm not even saying never use it, it has its place, but be crystal clear that you cannot guarantee that the data that you retrieve using no lock is accurate. And we see we're still, you know, as long as we run that, we're going to be generating a page split here and there, right? And this is not that unreasonable. It's contrived with the clustered GUID, but you know, updating 10% of the rows in the table each time, that's pretty reasonable just for something that could be happening in a production system, in a busy system, right? So you look at that and you say, okay, well, that's using a GUID for a clustered index. If I choose my clustered index correctly, if it's my identity column, so that I'm just adding rows to the end, I'm never going to have this problem. And that is not true, because that's only one of the things that can cause page splits. Probably the most, if you have a well-designed database, probably the most common cause of page splits would be variable length data types. Say I have a column that's varchar 500, but most of the rows in my database only have 50 characters. The difference between a varchar and a char is that it only uses the storage that it needs for what you put in that column. So it's only going to use 50 bytes, right? Well, if I go update that and I change my 50 to 350, there's a good chance it's not going to fit on the page it's on anymore. So that's going to cause a page split because we have to allocate a new page and move things around to make room for my new value. So this is really important to understand, and it tends to surface itself in interesting ways that are intermittent. Things like, you know, I'm getting a primary key violation when I go select from this table and insert to another. Well, that's because you got duplicates and you're trying to insert 2 rows, even though you queried based upon the key and you with no lock, and you said, I want just this row, but you actually got 2 rows because there were 2 of them. And when you went to go insert those in your other table, you got a primary key violation because you tried to insert 2 rows with the same key, right? You know, inconsistent results on reports are other ways that this will come up. So it's really important to be aware of. Okay, that wraps up the demo. There's just a few things here in terms of resources. I know we're at 12 o'clock, so we need to wrap up. If you are a developer and you've attended this and you're writing code and you know, I don't want to be the one that's causing these issues, but I maybe don't know enough to figure out how not to, talk to your DBA if you have one. Talk to someone in the community. People would rather help you do it right than have it go to production and have you say, but it worked in dev, right? Our next webinar will be in May, May 12th. Scott Klein will be doing that on hybrid high availability. So if you have an on-premise availability group and you want to extend that to the cloud for off-site, what does that look like to put a replica in Azure, for example? So, all right, Q&A. I don't know if we got anything else, but we'll open it to that at this point.
Yeah, there were a couple more comments. And for all those still on, I shared a link to register for next month's webinar. Made that easy for you in the chat.
Try using ITV instead. ITV. Are you talking about table valued functions? It sounds like that's probably what it is. Yeah, there are definitely ways to do things like what I did with the UDFs to make it more efficient and still be somewhat reusable. The point of it is to always look at what's happening behind the scenes to make sure it's doing what you think it's doing. Okay. Let's see this comment. Excellent no lock. Showing the row count change will make a bigger impression on our devs than showing them page splits. Absolutely. Page split is theoretical, right? To developers, right? But not just developers, but management, right? If you show a demo like that to management, that this data will not be right if we're doing this, that will tend to open some eyes, right? Particularly in areas like, oh, we use no-lock for everything in reporting, and we do our financial reporting that way. And now you're telling me that my numbers may not be right for my, for my SOX audit. That's a big deal, So appreciate everyone attending. If there's any other questions, happy to stick around for a moment. If not, hopefully this was valuable, and we'll see you next month for the next webinar.
Awesome. Well, for all those still with us, we will be sending out the video for this probably this afternoon. So watch for that, and thanks for joining us, and we'll see you again next month.
All right.